Hello and welcome to my presentation on how a frameshift mutation can result in the production of a shortened non-functional protein. Imagine yourself waiting in line for a new roller coaster with some of your friends. You've been waiting in line for roughly an hour when you notice somebody quietly cut into line. You brush it off as no big deal until you're about to get on the coaster where you come to find that there are only 3 seats per row on the ride. Now you are forced to sit alone without your friends solely because one person thought it would be acceptable to jump the line while everyone else was waiting patiently. Because of this one person, everything's messed up. They negatively impact your experience at the theme park so much that you just decide to cut your trip short and go home. Unfortunately, a similar thing happens during the synthesizing of proteins as a mutation along the gene or a kink in a sequence of DNA known as strand slippage causes there to be a nucleotide that jumps the line. In this example, there is an addition of an adenine to an RNA coding sequence, causing there to be a shift in the reading frame in all of the codons after said addition. Highlighted in blue is cytosine, which was impacted by this addition as it is pushed into the next reading frame away from its original codon, causing the production of isoleucine rather than phenylalanine. Ultimately, frameshift mutations make deciphering RNA coding sequences very confusing. However, when the mutated and normal amino acids are given, the coding sequences can be found using a codon table and a chart. We first look to the codon table to determine every possible codon that can be translated into the known amino acids and place them into the table. We then look to see where the variation in amino acids begin between the normal and mutated proteins, in this case, phenylalanine and isoleucine. We then need to match up the final nucleotide in each normal codon and the first nucleotide in each mutant codon to determine which variation was used in translation. We follow this until we reach the stop codon, UAA. This stop codon was produced due to the frameshift mutation causing the premature stoppage of translation leading to the creation of a shortened, limited, mutated protein.